As we said, there are many different devices that we can use to connect a network. And each device has its own level of intelligence. And I don't mean the intelligence of the person that's using it to put it in their network. I'm talking about the intelligence of the device itself. So we're going to talk about intelligent devices. In other words, we're going to talk about devices that can help us to separate our network into separate collision domains. Before we talk about separate collision domains, let's talk about a device that does not do that, namely the hub. A hub is just an electronic bucket. A hub is just a way of distributing electrical information. In other words, if I took a bucket and I filled it full of water and I put it on the floor and then I shot it full of holes, where would the water come out? And obviously the answer should be out of the holes. But now I'll ask, which holes? And what you should say is, well, all of the holes. Well, that's what a hub does. You put electrical information into it and it comes out of all of the holes. But there's no intelligence. There's no filtering. There's no selection of that information. So a hub is just an electronic bucket. There are two types of hubs. There are powered hubs and there are non-powered hubs. A powered hub obviously has a power supply. It's got a plug plugged into it somewhere. It's plugged into a wall, and therefore it can be a multi-port repeater. A repeater just amplifies signal. But a repeater doesn't do anything to the signal. So a multi-port repeater just amplifies signal, and if the signal happens to be garbage, then what you get is louder garbage. So it doesn't help with segmenting the network. It doesn't help with filtering any traffic, but a hub just allows us to electrically connect devices throughout the network. Now, going up one level of intelligence is a bridge. A bridge actually does make decisions. Bridges work at layer 2 of the OSI model. Hubs work at the physical layer, the bottom layer of the OSI model. Bridges work at layer 2. So bridges can make decisions based on what address? Based on a MAC address. Remember that at layer 2, that's the only kind of address we have is a physical address. So bridges make decisions based on MAC addresses. And the decision that they make is they take a look at a table that they form. And they say, okay, well, if it's in my table, I'm just going to send this particular packet out the port that the table says to send it to. But if it's not in my table, then I'm going to send the packet out all of the ports except for the one that it came in. That's called flooding. And you should know that term. Flooding is sending a packet out all the ports except for the one that came in. And it happens when a bridge does not have the information to send the packet out of just one port. So bridges learn, and they can segment a network by MAC addresses. Now, switches are just like bridges. Switches are fancy bridges. They're programmable bridges. And switches are faster because switches are typically designed just to do switching. In other words, whereas bridges use software, which is typically slower than hardware, switches actually are little computers that are made just to switch. And switches use that same type of decision, but switches can be further programmed. For example, you should know that switches can be programmed for store and forward, which means every packet I receive, I'm going to receive that entire packet, make sure that it's not damaged, and then I'll forward it. So switches can make those types of decisions. We can store and forward. We can do cut through, which just means as soon as I receive a packet, it goes to its destination. As soon as I see the destination address, it goes to the destination. The third choice in the programming is fragment free. Basically what it does is it tries to determine whether this packet is damaged or not. So it looks at the first 64 bytes of the packet just to determine whether it looks like this packet has been damaged. So switches can be programmed, and we'll talk more about intelligent devices that can be programmed. But switches and bridges make the same types of decisions. And I know that just going through that seems very complicated as to exactly what they do. So let's take a closer look at an example of a switch or a bridge in action.